Hello Stats class, this is a question from our chapter 10.2 homework, and it's asking us to look at these 10 points here. I'm going to blow this graph up so we can see it. So these 10 points, there's 9 right here, and then there's one more down here in this corner. And the question is asking us, first of all, do we see strong linear correlation? Now this was sent to me, so it was already answered. So the choice here was noted that there does appear to be a linear correlation here because these are the low x values down here, and we have high y values for these low x values in general. And then we have this one point that's basically probably like an outlier, you know, if you compare it all to the rest of the data. But because that one outlier is a high x value, has a high x coordinate relative to all of these, and a low y coordinate relative to all of these, it looks like we have low x values correspond to high y values, and high x values correspond to low y values. So that is a strong linear correlation when that happens, when we have like a perceived pattern in the data like that. So that's why yes would have been the answer there. Now, what is the value of the correlation coefficient for all data points? So what we want to do here is take our calculator. I'm going to blow up the graph again. Alright, and in our graphing calculator, if you press the stat button, you can go into the list editor, stat enter, and you can put in data points here. If you already have data in, just highlight your list name and hit clear and enter. Highlight list name, clear, enter. You can also do second memory, and then option 4, clear all lists, and then it'll clear your list also. Okay, but once you're in the editor, you put your x coordinates in here and your y coordinates in here. So I'm going to come over here, and my x coordinates, if you notice the dashes, these all have an x coordinate of 1. So 1, 1, and 1. Okay. These all have an x coordinate of 2. These all have an x coordinate of 3. So 2, 2, 2, 3, 3, 3. And then this last one, the 10th point, is at 9 for the x coordinate. Okay, and then we go over to the y's. So the 3 ones, I have a 10, a 9, and an 8. A 10, 9, 8 with the 2's, and then a 10, 9, 8 with the 3's. Okay, and then this 9 right here has a height of 2. Alright, so once I have all my points in there, I'm going to hit stat, come over to calculate, and then I want the linear regression equation. So option number 4, and hit enter. Okay, now there's all my values. There's my value for R. Alright, if it doesn't display this for you, you can hit second catalog, and then you're in alpha mode when you see this letter up here. So in your alpha mode, your keypad are the letters. So I'm going to go to the D letter for diagnostic, and I'm going to scroll down until I see diagnostic on. And diagnostics on will turn R squared and R on when you do regression. So diagnostic on, and then if I didn't have it in there before, it would now show up after I turn the diagnostics on. I would see this. So R is negative 0.880. So back to this question. So remember, R has a sign value with it. So the reason why this one wasn't counted correctly is because we didn't have the negative in there. This is a negative R. Alright, and then the rest of this question asks, is there a linear correlation between x and y? Use alpha equals 0.01. What we have to do there is look at this table of critical values. Alpha equals 0.01. N is the number of data points in the table. We had 10 in ours. N is 10. We need the absolute value of this to be bigger than this number. So 0.88 is bigger than 0.765. So that means that there is a linear correlation, which corresponds to B. Okay. Critical region is just anything above this in absolute value. So that's what we mean by the critical region. Alright, and then the last part, what is the correlation coefficient when the 0.92 is excluded? So what we have to do there is go back into our stat editor and just go down to that very last point and take away the 9 and the 2. So I'm just going to delete and delete. Alright, and then I'm going to go back, second mode. I'm going to run the linear regression again. You can, since this is the last thing I did, I can just hit enter on the calculator. It'll run it again. And notice this time we get r squared is 0 and r is 0. Okay, so it's just that. Is there linear correlate? Well, no, there's not going to be, because we have to be above these numbers and we're at 0. So no, the correlation coefficient is not in the critical region. Alright, and the outlier is what's causing this. Okay, what do we conclude about the possible effect of a single pair of values? A single pair of values can be completely different in the other direction with these questions. One single point can make something go from no correlation to strong correlation, just from one point.